Solving for the roots of the quadratic equation is a well-known mathematical problem. This video shows the user how CADWOLF can be used to solve this problem and explain those results to the reader. In doing this, we use text, symbolic equations, and equations with a built-in vector function, as well as the root and power functions. We also create a standard line chart. This is what the document will look like when we finish. We're going to go through step by step and show how each element is added to the document and then edit it. Before we begin editing the actual document, we first open the File Properties view and change the title. We decided not to give this document a subtitle. We start the document off with a text block that explains to the reader what the document will contain. This was done by simply clicking on the icon for a text block in the edit bar on the left of the page, and then entering the desired text. Next, we add a symbolic equation to the document by clicking on the line in the GUI. The first symbolic equation shows what a quadratic function is, namely any function with a linear and quadratic element. The second symbolic equation shows the two solutions for the roots of that function. Note that the roots depend upon the constants a, b, and c, and that the roots are merely the values of x where the value of the function is 0. Now, we change the format of each of those symbolic equations so that their widths are 400 pixels and they fit in the same line. After this, another text block is added to provide the reader with an explanation of what follows. Now it's time to do the math. We add an equation to the document and set the text to a equals 6. Remember that we often refer to equations as variables. Adding two more equations to the document, we set those to b and c with values of 9 and 2. Once this is done, we change the formatting of each equation so that their width is 272 pixels and all three fit on one line. After the equations, we add another text block to help explain to the user what's about to happen. Now, we add an equation and solve for the first root. Removing the default text, we change the equation to what you see here. Note that we use the root and power built-in functions, and that we use the / to represent division. Also note that when the solution is displayed, it is displayed in the proper numerical format for the exponents and the division. The same process is carried out for the second root. After we add another text block to explain what we're about to do, we add another equation and create a vector named x and use the built-in vector function. This function is invoked by entering an open square bracket, a starting number, an increment number, and an ending number, which are separated by colons and followed by a closing bracket. Adding another equation, we use the power function and set a variable named y to a times x squared plus b times x plus c. This is a quadratic function using the coefficients above. Note that CADWOLF recognizes that those items are vectors and treats them accordingly, with the result being a vector of the same size. Finally, we add a chart to the document. Clicking on the chart, we open the type window and select line chart. Opening the data window, we name the vector y and enter the two vectors we just created, x for the x data and y for the y data. Note that you must hit enter after the text is entered in each input box to secure the changes. After that, we open the title window and ensure that the title is showing and enter the desired text. Finally, we go back and we change the appearance of the plot to remove the data points. What this means is that there's a circle showing for each point of data on the chart, but that isn't really necessary and it takes up a little bit of extra memory. So we go back and remove those points so that only the line of the chart is showing. Finally, we open up the y-axis window and we change the axis label. This changes the text that appears on the side of the axis. Note that you can change any of the equations above, and any equations that depend on those, as well as the chart, will update automatically. Here we change the coefficient, and the roots and vectors update as well as the chart. Well, that's it for this example. If you want to keep up with everything that's going on, follow us on Facebook and Twitter.